section 5.6 is all about application of vectors. And for especially this section, I strongly recommend you guys to watch the separate video that is already uploaded, the UC Scout video. Because that video, it categorizes the types of application of vectors very clearly, and then thorough step-by-step approach is already explained in that video, right? So what I prepared for today in this instruction is I actually took the same problems from the practice problems section 5.6. And I will explain the actual approach steps for you guys to do better when you try the asynchronous assignment on Thursday. So this might be really helpful. So this Thursday, do not forget to attempt that assignment, okay? Okay, the first example is this. This one was categorized as the type of the application of vector as the velocity. And this is the simplest type, yeah? And someone kicks a soccer ball at an angle of 30 degrees from the horizontal at a speed of 65 feet per second. And the parts that are asking us to find is the horizontal component and vertical component. And this is a very simple situation that we can utilize one vector. And since we are given with the direction angle, which one is the direction angle from the context here? The 30 degree is measured from the horizontal line, right? So this is direction angle of the vector that we are using. Then another information given here is 65 feet per second. So this is the speed. Then on the vector, this is the magnitude of the vector that we are utilizing here, right? Okay, then in previous section 5.4, it was briefly explained. So if you're not clear why we are using next step, and you can always go back and revisit previous section 5.4 notes and record the video, and it was explained there. Then with this situation, and we're gonna use this formula for horizontal component and vertical component. Okay, then if you have this diagram, and it will help you to figure this out. And for our convenience, we consider the kicking point on the origin here. And now, the vector that we are using to indicate the trajectory of the ball that was kicked by this person will be this way. So now let's call this one as vector V, right? Then the 30 degree was measured from horizontal line, then it might be very, very clear for us to use that 30 degree as our direction angle. Because the way that we measure the direction angle is from the right side of the horizontal axis, and it goes counterclockwise up to the vector existing, right? So then from here, and then it measures up to there, and then we can call that one as theta, the direction angle. What is the measurement here? 30 degrees. And the second information that we are given with is the magnitude of the vector. What is the value? It's 65. So then in order to utilize this vector component, then all we need to do is 65, right, times for the horizontal, we're using cosine. Then direction angle theta is in this case, what? 30 degrees. Then horizontal, vertical component is 65 as well, but only difference is sine. What is the angle? 30. Then the calculation, I would not go over even that steps. Then you should be able to find the values properly. And when you actually trying the practice problem later, in it might be given as different types, but you should be able to figure what's what, right? So this is just approach that you need, right? And also, I added the next slides with a little more detailed approach there. And then if you want to revisit this recorded video later, and then it will help you with the uploaded notes altogether. Okay, any question? Okay, then let's move on to the next example. So this particular type of the application vector will be categorized displacement. This is just simple. When you utilize the fact that we can place the necessary vectors, the multiple vectors on the quadrant. So that's why I have this two vertical and horizontal axis and making the quadrant there. And now you will see how we can utilize multiple vectors with the directions step by step. Okay, then we can figure out the final destination here. So all we need to find is total displacement. That means after you follow the context with 5 kilometers due east, 4 kilometers due south, then 3 kilometers due west, then from the starting point as the initial point and heading to the final destination as the terminal point of the new resultant vector, then that's all you have to find, okay? So first step that you have to do is you label this four sides of that axis, four ends of axis with the direction properly. And we start from north. And for our convenience, I will label the top with north. Then if that's defined as north, and then the opposite, the down, it's south. And once you utilize the vertical axis with the north on top and south on the bottom, and you have to be really careful to properly label west and east. And with this north and south, the left side of this vertical axis is west. So this is west. Then the last one will be labeled as east. Then let's follow the context here. First, 5 kilometers due east. So that means if we start from the origin, we go to the right and we can utilize 1 kilometer by 1 unit, and then simply we can go 5 units to the right. Then now, first vector could be this. Due east means there's no diagonally tilted angle measure. It's just directly to the east. So we can expect this horizontal vector there. Then from there, this person moved 4 kilometers south. So here, and then now we're moving 4 kilometers to due south means it's 1, 2, 3, 4 down here. So now second vector will be here. 1, 2, 3, 4. Maybe I can erase this. before. So 4 units down, then change the direction due west and 3 kilometers. So that means it goes 1, 2, 3, 1, 2, 3 to west, right? So then with this story, then if we find the total displacement as the resultant factor from the initial point, and then the final destination currently is here. So then this is the new created vector that we're looking for, right? Then how do we find the vector? And either you can find the component form, or it's possible that you can find it as the linear combination of I and J, either way. But here, all you have to do is you find the resultant vector, and then this is 2 units to the right, and what? 4 units down. So you should be able to the values for the component or linear combination of the vector either way, right? So that's pretty much it. All you have to do is you label 4 ends of the quadrant with north, south, west, east properly, and you follow through the directions, right? And then each vectors are working as operations, and then the resultant is going to be from the initial point as a starting point and the terminal point as the final destination there. And all you have to do is you find the component, either component form or linear combination. Okay, so that was it. And I added one more, the next slide with color-coded story and everything, and then it will help you to do the assignment later. Okay, so any question? Okay, the first one, second one is pretty much straightforward and it was simple. But third one might be a little bit more complicated, and pay attention, okay? So the third one, simply we are using multiple vectors that indicate different aspects. Then we get to operate the 2 vectors. Then the resultant vector is just the calculation result, the vector operation result of this 2 vector. So the key is we will use one vector to indicate the potential of motorboat, and the other vector is the current, right? And we are given with the magnitude. Why do we consider this one magnitude? Because these are the speed. These are the speed. So we're not given with the direction angle of each one, but we can still utilize with this due west and the due north as a direction. And also we do know each vector's magnitude, which is the length, right? Then after we see the situation with 2 vectors, and then we can find the resultant vector. So from first vector and the second vector, and just like we did before, and starting point as initial point, and the last terminal point as the terminal point of the resultant, and then that makes the situation a lot easier and simpler. Okay, so first we will use vector M. Let's call vector M and indicates this vector and represent the motorboat, right? So then what we need to find is the component of the first vector m. What we have is magnitude of vector m, which is what? 7. Then now first vector m, we start from the origin, and then this is north, this is south, and then this is west, and this is east. And it's heading due west, right? So it's gonna go to the left. Its length, the magnitude is 7. Magnitude is 7. So it's 7 units to the left, right? Then what's the direction angle here? What's the direction angle? Let's say direction angle is measured from right side of horizontal all the way to the vector existing here. So in this case, the direction angle of this first vector m is 180 here. So this is the red theta there. So it's 180. Then according to the steps that we did in previous example, so it's gonna be what now? Magnitude times cosine 180, that's horizontal component. Magnitude 7 times sine 180 is the vertical component. Then if you calculate it, and it's gonna give you -7, 0. Then it makes sense to us because the vector m is just horizontal and it only has the length horizontally. There's no length vertically, right? So it makes sense. Then we can figure out the second vector. Let's call the current vector with vector c, and then we will figure the components here. So then what's the magnitude of vector c? Magnitude of vector c is 3. Where do I get it? Here, right? Then on tip of the first vector, we can continuously put the second vector there. So it's gonna start from here, and then it's heading north. So from there, it's directly heading north, but how long? It's 3 units, 1, 2, 3 units there, right? So then, if I measure the direction angle of the vector c from the initial point of the vector c, and this is the theta of that green vector c, and then it's 90 degrees here, right? So then the green theta, the vector c, the direction angle is 90. Then same manner, I can find the component for vector c, like 3 times cosine 90, 3 times sine 90. And then you should be able to get it with 0 and +3. And then it makes sense because there's no horizontal length, so which is 0. And then there's only the vertical length up 3 units, and then it's gonna be 3, right? So now we have both motorboat vector and the current vector there. Then consequently, we are finding magnitude of the resultant vector. So then where do I find resultant vector? The resultant vector will start from the initial point of initial vector, and then it's gonna go up to the terminal point of the terminal vector. So then technically this blue vector, and then let's call it vector R, resultant vector, indicates the actual heading route, right? Even if that motorboat intend to go straight to the west, there is some force from the current pushing it due north, and then it's gonna be a little bit tilted towards north, right? So that's why we have this result here, right? So then magnitude of this blue vector R will be, because vector R will have the horizontal component -7. It has horizontal length 7 units to the left, and the vertical length 3 units positively, right? Then magnitude of vector R, which is the speed of the ground speed, actual speed, is gonna be square root of -7 squared plus 3 squared, which is square root of 49 plus 9 is 58. So we found the magnitude there. Then now, here comes a little bit more complicated things going on. Now, since we know the component of resultant vector R, as we practiced in the previous section, we can find the direction angle from this ratio. So tangent what? Inverse of vertical component over the horizontal component. And then if you calculate it, it's gonna give you what? -23. I calculated in advance, -23.19 here. But since the current position of vector R is quadrant 2, this is not direction angle from the right side of horizontal axis all the way to the vector. This is what? This is theta prime in there. So this is theta prime there, right? So then the true horizontal, true direction angle for this vector R, starting from the right side of the horizontal axis and all the way to the position of the vector R is this, right? So then in order to find this true direction angle of R, it's gonna be 180, right? 180. So the real yellow theta itself is 180 minus 23.19, and you should be able to find the value there. So that should be equivalent to the actual direction angle of the actual resultant vector R. Then you will see little more thorough approach on the next slides here, okay?